lands on top of the third. And then your seventh one on top of the sixth one. And then you're just going to tuck that first one over the ninth one. And that forms your hexagon. Now what you want to do is you want to tape. So here you have those two that are sitting on top of each other. Tape them together along this top edge. So just take a small piece of tape. You don't want it to be too big because you don't want it to cover more than just that edge. Yeah, it's black for this purpose. And then you just place half the tape on one side and then just fold it down over.
Perfect world, it all lines up.
In a perfect world, it all lines up. And you made a flexagon. So we're all set. So now when I do this with the teacher circles, I start by talking a little bit about, oh, did you tape?
No, I didn't.
So once you have your top one, your ninth one underneath,
Tape it.
tape
Just
it along this common edge.
along the edge.
Along the common edge, that's right.
And fold the tape over.
And fold the tape over. So as I said, when I do this with the teachers, they don't really know about symmetry groups, and so we start by just talking about the symmetries of the hexagon itself. And we talk about rotational symmetry, and then rotational symmetry in the plane of the hexagon, but then also rotation about a line of symmetry through the center. So instead of reflecting, we think about rotating in space.
And I think that is the pattern that
I define a symmetry simply as an undetectable motion. So if I rotated this and you weren't watching, you wouldn't know that it had been rotated. If I flipped it across that horizontal line, you weren't watching, you wouldn't know. And then we talk about the fact that you can do an undetectable motion and another undetectable motion, composition, is undetectable. So then we spend some time talking about, well, what are all the symmetries of the hexagon? And they realize if you rotate 100 degrees about one line of symmetry and 180 degrees about another line of symmetry, they realize that that actually was the same as rotation. And if you rotate twice about the same line, it's as if you didn't at all. So then you can set up some algebraic relationships between the rotation and the rotation about these lines of symmetry. And that part of the activity gives them an idea about they have to use composition functions. They have an operation that's not commutative. They learn how to, when they multiply two of these products together, then they have to do modular arithmetic because if you rotate 6 times, you're back to the identity like this. So just that part of it by itself is very rich in terms of algebra and functions representation. But then we get to this really interesting part, which is what intrigued both has shown when you found this. And that's there's another motion that sends this object back to itself, flex. So that's where the flex from flexagon comes from. So the flex, now before we talk about how to flex, fold along each of those triangles. If you notice, these triangles that make up the face of your hexagon, they're along these radial lines. There are two types. There's one where you see a little pocket and you slip your finger inside, and there are others, neighboring ones, that you can't. So if you have a little pocket, we call that a slit. And if there is no pocket, we call it a hinge. And so what we want to do for our flex is we want to, have you guys all done R&M? You know, mountain folds and valley folds? So a valley fold, it sounds just what it sounds like. When you fold it, you created a valley. Whereas a mountain fold, when you create a mountain peak. So what we want to do is along each of those hinges, we want to valley fold it so that all three of the hinges meet together together right underneath the center. And sometimes it's easier to do that if you mark your hinges. So I'm just going to draw a red line on each of my hinges. Because the first time you do it, it's not so
The
obvious.
hinges are in different places on the top and the bottom. Does that matter?
We're just going to look at the top for right now. And so we have these three hinges that make their symmetric about the center. So between two hinges, you form a 120-degree angle. And then it's easiest if you put your finger underneath the center and you push those hinges down so they meet right under the center. So what you're going to want is that first one on top of the ninth one, and then you take right along this edge. So mark your hinges, push those hinges down, and like I said, if you put one finger underneath the center, it makes it a little easier. So you're valley pointing all those hinges so that they meet together underneath, like that, and then you put it up in the middle. And now your hinges are not, you have a new face, like Phil said, so the hinges are in different places now, but you can do this again, right? And if you do it a few times, you start to get the hang of it. So valley fold your hinges down. And after you've done it a few times, it happens just automatically. So did you see that?
No.
Okay. So you have your hinges, and you want to mark your hinges. So the hinges are the radial lines that do not form a little pocket.
Not on these pockets. So we just push those corners down.
This one.
So there'll be three that are symmetric about the center. Flexing? Are you flexing? Pardon? Are you flexing?
I think so.
Okay.
I think it's flexed.
So notice that when you flex, it sends it back to the hexaflexigon. That's why it's called the hexaflexigon. So you flex and get your hexagon back. So now the question is, what's really going on when we flex? So because this is symmetry is an undetectable motion, things could be happening that we're not aware of because these motions are undetectable. So what you want to do, just like when if we had spent more time looking at the symmetries of the hexagon, we would have labeled the vertices so you could see the effect of each of those motions. So what we do here is we think about how can we make a design on this so that some of the motions that are going on become apparent. So first thing that we do, something very simple, we can just color one of the faces.